Hello, everyone. Welcome to Karmada community meeting. Today is August 6, 2024. Um, Today we have so many topics. I'm not sure if we can go over all of them. So let's try. Okay. Yeah. Let's uh, let's get started.
Yeah, so we have the proposal. Maybe Leon can go through the proposal. I also put a link in the Zoom chat.
Cool. Did I share my screen? Are you guys able to see that one?
Yeah, I can see.
Oh, okay. Awesome. So our team put up this workload priority and preemption proposal together. So currently the Karmada scheduler operates based on a first in, first out scheduling order. And this approach could possibly lead to suboptimal resource utilization. And especially in the case where less critical workloads are scheduled before important ones. So we want to be able to respect the priority class annotation.
Sorry, Leon. Can you zoom out your screen? So
Okay,
yeah,
sure. Is this better?
yeah, better. Okay. All right, that's
Yeah,
good.
cool. So in order to address this issue and schedule high priority jobs before normal priority jobs, we want to introduce the priority and preemption mechanism at the cluster resource binding and resource binding level. And these mechanisms will enable the scheduler to prioritize more critical workloads and preempt less important ones, and ensure that resources are allocated in a way that can align with our team and organization goals. So mainly, the goal of this proposal is we want to implement a mechanism to identify and recognize resource bindings priorities within Karmada, and also have higher priority workloads to be scheduled before the rest of the workloads, and enable higher priority jobs to preempt low priority jobs within the same cluster. And then we're going to make this customizable, but assume that we'll preempt lower priority jobs regardless of namespace whenever compute resources are insufficient for the high priority workloads. So of course, we'll make this most of these hide behind a feature gate, so users can choose to opt out or opt in into the preemption. And we also want to allow granular control over preemption at the binding level to enable and disabling preemption for specific bindings. So it could be like batch workloads only in our case. And then we want to ensure full compatibility with the existing Karmada features. And then this should not introduce any breaking changes into the existing Karmada workflow. And in order to do that, we'll also design a requeuing mechanism for the preemption to preempt lower priority workloads and ensure they are rescheduled efficiently. And in this proposal, we're not considering the more complex priority schemes beyond using a single numerical value to define the priority value, as the Kubernetes priority class is doing. And we also want to automatically determine the priorities for work. And also, we're not going to automatically determine priority for workloads. This is going to be user defined. And we're not going to touch anything other than the scheduling part, not related to scheduling part in Karmada. And we're also not considering the spread constraints. And last but not least, we're also not going to consider the elastic jobs, for example, PyTorch Elastic. And then the motivation to elaborate further with some user story is, as a user, in the first scenario, I want to schedule a more critical production workloads with higher priority than the other development and testing workloads that are currently running. And then it could be very urgent. And in another case, I'm a machine learning engineer using a multi-cluster environment developed by Karmada, and I want to deploy a critical AI model training workload that requires a lot of GPUs. And this is pretty time sensitive with high business impact. And I expect Karmada, when I submit the job, to recognize it's a high priority job, and if necessary, to preempt low priority workloads and quickly allocate the required GPUs. And then I want this to be scheduled, even if it means to free up GPUs from less important jobs. And on the other side of the story, for users of regular priority jobs, I don't want my jobs to be preempted unnecessarily, and also I want them to be requeued soon after it has been preempted, instead of me manually requeuing the job. And also, as a side note, we want to introduce the priority in such a way that users cannot easily arbitrarily set their priority for the jobs, and so that only clusters or managers will be able to define the priorities. And then here is an illustrated diagram of what we imagine the workload changes to Karmada will be. So to replace the first in, first out queue, we'll be using two priority queues, one to represent the back-off workloads, and another one to represent the active queue that's waiting to be scheduled. And then after the workloads that has passed the grace period or backup times, they will be sent from backup queue into active queue. And then the highest priority resource binding will be popped off for scheduling loop, and it will go through the normal first three of the scheduling steps of Karmada scheduler. So we're proposing that in the third step, when it's trying to select clusters using the resource estimator in accuracy mode, what happens is it will send gRPC requests to each of the resource estimator for the cluster to find the maximum replicas for the current preemptor workload. And then the resource estimator will tell the scheduler that it's not possible on any of the single clusters. And then the second step is it will send another gRPC request to find a possible set of preemption victims. And then once the scheduler defines which cluster has the best set of preemption victims, it will choose that cluster for preemption. It will delete the binding spec.cluster field in the preempted binding resources, so that the controllers will evict the work object corresponding to these resource bindings. And then in order to identify or requeue these victim resource bindings, we're thinking to annotate the reschedule trigger at field of the resource binding spec. So the scheduler will put it back into rescheduling queue. And then, so after modifying these preemptive binding spec, the execution controller will evict orphan workloads, work objects, and delete the workloads in the memory clusters. And then for the preemptive bindings, it will be requeued, put it back into the backup queue. And for the preemptor binding, we want to introduce a new field called the nominated cluster. So it's like Kubernetes nominated nodes. So it's like a suggestion for the next scheduling cycle, so that the preemptor, after the preemptees are terminated after a grace period and preemptor starts scheduling in the next scheduler cycle, they will consider to put it onto the nominated cluster first. So similar to Kubernetes preemption algorithm, the preemptor is not guaranteed to be scheduled in the next scheduling cycle. Yeah, this section talks more about how to replace the first in first out queue with our priority queue. So for example, we want to preserve all of the existing functionality while also make the requeuing time to be customizable. So the preserved functionality includes rate limiting to prevent excessive API server load, backup mechanism, efficient handling of large number of items, and support for delayed item processing. And then, to further elaborate on this diagram, the API changes we want to make includes the resource binding controller should also patch the custom resources priority class name into the resource binding spec, and specifically into the replica requirements, as these objects are sent to the resource estimator for calculating the victim resource bindings. So in this case, yeah, the replica requirements should also have these fields, priority and priority class name. And we also want to add the nominated cluster to the resource binding level. So in a resource binding, it'll have like preemption policy, which is already in place, and it'll also have like nominated clusters. This is to indicate that the cluster will represent this clusters, in our case a single cluster, represent the target member cluster that will be, or that the preemptor workload will be scheduled on, preferably. And then we also want to add the reschedule trigger. Yeah, we want to also add the reschedule trigger add field. Not add, we want to annotate this reschedule trigger add field for the victim's resource bindings, so that the scheduler will know that these victim resource bindings are kicked off and should be attempted for rescheduling after preemptor has finished. And then on the side of the resource estimator APIs, we want to also add another request type called preemption request. So it will include things like the cluster name on this preemption request sent out to, the replica requirements of the preemptor workload, as well as number of replicas that the preemptor workload requires. So replica requirements times number of replicas will represent the total number of resources required to free up for the preemption to work. And then, yeah, and then what this field contains would be like no claim, resource request, namespace. Yeah, it's yeah, just to reiterate. And then the resource estimators, when asked to provide a list of victims to preempt, the response should look like this. It will return a list of object references of the victim resource bindings. And then once the scheduler receives preemption responses from each of the clusters, it will then go through some logic to decide which cluster that to preempt and then to schedule the preemptor. Ideally, it will be the cluster with minimum number of workloads to kick off.
So because I close it, so
And then the preemption flags, we want to make this behavior to be set through a global feature flag on Karmada, and then when enabled, users can choose whether to enable preemption for the pending bindings. We're also aware of the elastic versus non-elastic workload and service versus batch workload. So the priority preemption algorithm can be different in these cases. So you want to make different flavors of the preemption algorithms configurable, and then implement it as a plugin in a Karmada scheduler. And in terms of preemption order, for our use cases, we want to minimize the number of bindings that needs to be preempted, so that we can reduce the impact to the other users when a higher priority jobs are scheduled. So because of that, we'll not always preempt the lowest priority job first, but we'll focus on preempting the smallest possible set of bindings with low priorities. And then in terms of how to implement the preemption algorithm, when it's sent to the resource estimator, so if it's a large cluster with like tens of thousands of nodes, we can just use the same greedy approach that Kubernetes pod preemption currently uses. We'll sort the preemptible resource bindings in a preferred order preemption. For example, all of the preempt victims in consideration have the same parameter, same priority class, and then we'll just sort the workload with most resources at the front, and then keep accumulating these victim resource bindings until the accumulated resource released compute resource satisfied the preemptor pods or preemptor workloads requirements, which includes like if all of the actual nodes will be able to fit the preemptor workload. And then this is really a stretch. So similar to how the resource estimator accuracy mode works for cluster admins who want to have really minimize the impact to user when doing preemption, we can treat this as a knapsack problem, maybe a 1D knapsack problem, where FW would represent the minimum number of resource bindings / user workload to preempt in order to free up W compute resources. So in our case, like GPU is our top concern, so W could just represent number of GPUs or a weighted number of CPUs and other compute resources. So we'll represent that with a single number, and then we can populate this solution F under NW big O notation, where N is number of running resource bindings, and then W is number of GPUs. And then we'll just do a search through this solution F, starting from the smallest possible W number of GPUs to release, and to check each incremental W if the scheduling conditions will be met to schedule the preemptor. And we'll choose that set of victims to preempt. And then last but not least, like some implementation detail. Currently, how do we find the resource binding corresponding to a group of pods? So essentially, we want Karmada to be able to propagate this resource binding permanent ID into all of the pods on the underlying member clusters, so that we can group pods by their binding permanent ID and calculate if a cluster can run the required number of replicas in the preemption request. And to make sure all this implementation would work, we also have a test plan. We'll make sure it passes all the existing Karmada tests with no breaking changes, and add end-to-end tests to test the priority and preemption behavior. This includes that the bindings are scheduled by priority, and then preempt lower priority resource bindings for higher priority resource bindings. And we'll be able to simultaneously schedule multiple preempting resource bindings and see how the scheduler prioritize them. We also want to benchmark test the scheduling throughput after making the priority and preemption changes to the scheduling algorithm through a feature gate. And then for future plan, I want to provide option for the user to configure the preemption scope to decide if the algorithm will be able to preempt across namespaces or not, or across different workloads or not. That is the end of our preemption and priority workload proposal. Thanks.
It doesn't have a use one. There's no use for like the model.
Yeah, looks great. Yeah, the guy I invited leaves the meeting. I don't know what happened. I don't know what happened. So, actually, I think the proposal is pretty much close to what I think. So, actually, I talked this feature about 2 months ago on another Karmada user also has similar requirements. So he sent a proposal too. So I can link the another proposal to the agenda.
And then it goes to calculate. Right, so the CPU.miller value gives you.
Yeah, so basically, we also see that PR,
That should be.
the proposal.
You
That should be a part.
yeah.
Maybe we can like work together. So, I just create a channel under CNCF. So possible like we can use that channel like to discuss the details and set up like maybe weekly meetup.
So we know like this is about the reporting, right?
Yeah. Sure. Okay. So
And then basically the
So
user.
I invite you to the channel, and could you also invite the guys for that?
do you mean you have already created the channel?
I already created a channel, and I invite you, Yuri and Leon, in that channel, and then maybe we can.
Yeah, sure.
Yeah, I think this is the person who made the request. We're also aware of his proposal.
Yeah, so our requirements is like the two proposal are similar, so maybe we can converge and then discuss the implementation. So
Yeah, I think it's great. So we can work together to move this feature forward.
We're still in lockdown, so we're not pushing this.
PR, or I don't know if the PR is merged.
Lockdown, like we can still do.
Pure number, right?
Give me one.
VR clusters on the PW side, maybe like Thursday, Friday, depending on. But we'll see. Yeah, we'll see. They know what happened. I mean, it's just
1 second.
I just link the proposal to the agenda.
This here. Can you see it? No. This here. 4993. There. This one.
Yeah. 4993. This one. Yeah. Okay. just add the link. Yeah. So so given the today we probably don't have enough time to discuss this. So I can leave my comments of after the meeting.
Do you want us like to schedule maybe a weekly update for until October or November? Like we can keep catch up with this topic. We can find a time for both Chinese time and
yeah, I think we can schedule the regular meeting on the Slack. But I'm not sure if we can move so faster because in the next week I need to get ready to the coming KubeCon in KubeCon China, and we are going to release another. We are going to make another release at the end of this month, so I maybe I will focus the feature planned in this release. So I think we so can you share with me your schedule about this feature?
So at least in Q3. So first in Q3 we want to like finalize the proposal and maybe have some feature implemented, like most feature implemented, not like all of them. So then maybe we can have a pre-release and test it on our side.
Okay, so Q3 we still have 2 months, right?
Oh, our Q3 and our Q3 is like a middle of November. Usually can confirm.
Mid of November, right?
Yeah, it's like mid of October, sorry.
Okay.
Am I wrong? Our end of Q3 is middle of October. Is that correct? Or anyone from Bloomberg can comment on that.
That sounds correct, yeah.
Middle of October. Yeah. So
Okay.
the first thing is like we want to finalize all those the proposal. Like we have we agree on all the features and maybe the implementation details. And then in our side, we already have like Wei Chen, he is not in this meeting. He's playing with the priority queue because the job is more like two parts. So the first part is more like we need to use the priority queue instead of the work rate limit queue. And then preemption logic, it happens in the estimator. It's like we can do that in parallel. So how about like the community can find some people to review our proposal, and then also include He Junjie, He Jun, and
Yes.
we want to
Yeah.
convert the two proposal like.
Yeah. That's the guy He Junjie. He
Would you
is
invite him to the
what?
channel?
Okay. Okay. No problem. I think we can do it.
Or
So
Yeah, from our side, we can play with the queue part, and for the estimator, we can choose the greedy algorithm to for the preemption logic, and then maybe in in next in that maybe we still need two spring like 4 weeks for the implementation, and then we can give you guys a demo like to see how the whole thing works.
Okay, sounds good. So how about that? We can continue discuss the proposal maybe by offline, and the meeting we are going to schedule. Anyway, we can focus on uh, discuss discussing this proposal response, and probably we can start to implement some features start from September.
Okay, so maybe this month we can try to implement some of our proposal, and then
Okay.
can show you guys a very simple demo, like to see how the whole thing work, and then after that we can focus on the details, and then
Yeah, I think
also
good, nice.
no.
Okay, thank you. So how about let's move to next.
Yeah, I can take over. I just quickly wanted to go over the failover flag, failover information implementation.
Okay, I'm sorry, Aditya. I just took about 2 weeks vacation, so
Yeah, no worries.
I'm sorry for your feature. Let's just feature set. So
Yeah, so I guess I'll just quickly go over the proposal, and then maybe when like after the meeting you can take a look again and add your comments. But yeah, I think I guess just to give some context, this is for adding information regarding like whenever a failover happened, so that stateful applications, in our case like Flink, can use this information to recover and resume processing from like the previous state they were in. So for this proposal, I mean, for this implementation, we just included another field called failover history in the resource binding. And this has 3 fields. So yeah, one is when the failover happened, which cluster the failover originated from, and the reason would either be the application or cluster, how the workload was failed over. And yeah, so for this, I'll skip over some of the implementation, but essentially what we're doing is if I take the example of an application failover, when we go into the evict binding phase, I'm looking for the update failover status, which is going to look for, if I can go to this function. Yeah, so this is going to check whether any of these, I guess, failover types are true. So whether it's application failover or cluster failover. and it's going to, so we previously had a condition, but I actually removed it in in my current implementation. But it's essentially going to create a new failure history item with those particular fields, so the time, cluster, and the reason, and then it's going to add it to the binding. So that is like pretty much the high level change. There is also a few other changes. We're gating this feature so that it only works when I guess all the replicas are scheduled to a particular cluster. So that is like the spread constraints is one. And we are, so we only take care of that case because we're not worried. We're not thinking about the cases where a particular replica fails over in another cluster and it's like spread out. So only when all the replicas fail over together is when we allow this feature to go through. So that's the restrict failover information function. And there are a few tests. I added a comment for one of the tests that's failing. Maybe I can get your input on that later. And yeah, I guess other final change is we prevent the so like if a workload was failed over from, let's say, cluster A, we remove it from the following scheduling process that happens, because we don't want an application or a workload that failed due to application or cluster failover to go back to the same cluster. So yeah, that's the final change that we made in the filter cluster eviction filter plugin. I know you had a few concerns on how the resource binding, I guess, layout should be like, but our thinking was like origin cluster should be enough because this would kind of be a list. So like if originally it failed from cluster A and then it went to cluster B, we could, I guess, by using all the information in the list, we could piece back where the cluster was and where it got scheduled to, and so on, without, I guess, involving the scheduler component and making it a little more confusing there. So yeah, like just from using the origin clusters and the list format that we have, we should be able to piece together the flow of events. So yeah, I think that's pretty much high level, the changes I described. If you have, I guess you can take a look in your, whenever you're free, and then you can let me know if you have any concerns.
No, yeah, I think the failover history looks great, and I have one question. Since there is the only one cluster, that's the origin cluster in the history atom. So
Yes.
This is based on the assumption we made that only one cluster will be scheduled, right?
Yes. Yep. That's the that's what the gating, I guess, function does down here. So only when so yeah, if it is yeah, if the spread constraints is of like max group greater than one, min group greater than one, it's not being like we don't restrict. We restrict the failover information. So whenever the restrict failover history info is false, we actually update the failover status. Others we don't.
So it's only, the feature only impacts applications where replicas are scheduled together to a single cluster. So we don't account for cases where the resource is duplicated or if it's divided amongst clusters.
Okay.
Yeah, I think it becomes harder to define when a failover happens if only like one replica of the workload failed over. So we're kind of sticking to this assumption, I think, that we made in the proposal as well.
Yeah, I think one thing I'm sure that we need the eviction history item, no matter if we no matter if it needed by the failover feature, you know. That's the history is. I think that's the feature we left from the before when we designed the failover. I think that the history thing should be part of the failovers. So okay, I think I can look into the PR this week and let's try to make a final decision by this week or next. By the way, I think I really want this feature will be included in this feature in this release. I mean, at the end of at the end of this month. So, by the way, can you share with me your schedule about this feature?
Yeah, I think Mihash, you have any idea on next release should be fine with us.
That should be okay. What we have right now is this commit and the commit that I made related to the federated resource quota, essentially just cherry picked on top of a fork off master. And that's what we're using for our MVP. So however long it takes to merge it into master, like we don't, there isn't like a time crunch there. So please feel free to take your time and review these at your own pace. But I think in order of priority, the failover history is probably close to the top for us.
Okay, I know, I got it. So history is at the top, right? So I also can maybe I will. Yeah, I see Changjin is also in this meeting. Maybe he can help to look at this too.
That'd be great, yeah.
Okay. So I think we can go over one more topic.
Sounds good. Thank you.
Okay. Thank you, Aditya, and thank you, Mihash. Next, Mihash review the federated result quota, right?
Yeah, so this should be quick, and I just want to give a demo of the change that I made. So I think the last comment you left, you said we wanted to focus on the multiple pod template proposal. That's currently under review, so I just need a review on that proposal. But this feature is also pretty high at the list of what we require for MVP, so I went ahead and implemented it. So it's up for review if anyone wants to take a look at it. To go over it briefly. Oh my gosh, Zoom. Okay. So looking at the existing federated resource quota, the way that it's set up is using a static assignment. So you set your overall limits for CPU and memory or any other type of resource that you'd like. And then Karmada will go ahead and create resource quotas that are aligned with the static assignment that you've set for the specific member clusters. Now, this is fine, but the issue for us is when we combine this feature with failover. So in some cases, if you set the static assignment for the resource quota to be evenly distributed amongst member clusters, you can run into issues where you've scheduled an application on cluster A and that cluster fails, and you try to reschedule that application on cluster B, and there's not enough resource quota there for your application to get scheduled. Now, there is a to-do in order to implement like dynamic resource quota generation. But the issue there for us is when it's coupled with failover, and we care about failing over applications as fast as possible, that would introduce an additional step where you would have to reshuffle the resource quotas amongst the clusters in order to accommodate for the applications that are getting failed over, which seems pretty complex. What I've done for now is essentially implement a default resource quota behavior. So you can set totals for the amount of resources that are used or applied to the Karmada control plane. And once your resources go above that limit, Karmada control plane will deny any requests that you might be applying new applications to the namespace for which the resource quota is at capacity. So if we take, for example, here is an example Flink deployment with however many resources here. Task manager takes up 1 CPU, so does job manager, and then we have 6 task manager instances. So applying this to our namespace, there is a federated resource quota that exists on this namespace and will get updated in line with every resource binding that's applied to the cluster. So here we can see the overall used is 7 CPU, and then the total memory. And the limits that we've set are based off of the overall. So for example, if we try to apply an additional application that encroaches upon our limit, we have a validation webhook that will tell you that the request is denied because the quota has been exceeded. And apologies, this is using not the latest, so this requested field is wrong, but it's essentially just checking that the requests that are needed for the application that you're trying to apply exceed the limits, and so we're going to deny that request. This also works for edits. So if we try to scale this application, then this will also be denied, specifically because of the quota that's getting exceeded. So I won't go over all the implementation details because I don't think we have enough time. But what this feature essentially gives us is a way to put a gate for the amount of resources that can be applied and scheduled by Karmada for a given namespace.
Okay, and did you do you the idea you does this implemented by webhook, right?
Yes.
Yeah.
So we have, I've altered the API definition for the resource binding
Yeah.
and the propagation policy to map to a specific resource quota. And then I've
Yeah.
added in an additional controller that's in charge of updating the federated resource quota's status to account for how many resources are currently being used. I've also added in the validation webhook, so that's running on the webhook server. And so that webhook is connected to the quota that you have defined on your namespace. And then whenever you create or update a resource on the namespace where a quota exists, it'll make sure that based off of the replica requirements for the resource that you're applying, that there are enough resources available on the quota.
I can get it. So it's the similar idea of a Kubernetes false checks the resource quota, right?
Yeah. So, and it is possible, since there are multiple controllers that are in charge of updating the federated resource quota status. I've also made it so that you can't switch between static assignment and the default behavior that I've implemented on the fly. You would have to delete your federated resource quota first and then reapply it with the static assignment for it to work.
Okay.
But yeah, if it's easier, I can also schedule some time in the next community meeting to go over the implementation a bit. But the PR is open for review. I think what I might do, if there aren't major objections to the implementation, is split up the commits into smaller chunks because the actual PR is quite large. So it might be smarter to merge in the API change first, then the controller, then the webhook. But yes, if I could get some eyes on the PR, that would be great.
Okay. So I just got back from vacation, so I didn't get a chance to look into it, but I will look at it as soon as possible.
Okay. And yeah, no rush. Hopefully you had a good vacation.
Okay. So so we are running out the time. So Joe, I didn't see Joe on the meeting.
Yeah, so Joe is on vacation. So I think those two proposals are just enhancement for a Karmada operator. So
Yeah.
we just like want to bring this to your attention. So if you can have some time to review those. So one is for the external SCD, we want to add a secret reference to the CRD. So currently we only support inline credentials, but currently we are using the GitOps to streamline the CRCD. So that can be like a security concern, and it's really cumbersome for us to put this inline credentials inside SCD. And yeah, so we want to put like a secret ref so we can use the Kubernetes secret management to populate the its SCD credentials. Another one is we want to add some extra volume and volume mounts for the API server pod on Karmada operator, because when we try to configure the encryption at rest, or we can add some custom authentication webhook, we need to mount the config file onto the API server pod. But currently the operator doesn't support that. So yeah, it's just we want to like have some reviews on these proposals. Yeah.
Okay, no problem.
Yeah.
For the short update, today I reviewed the CRD download PR. So it looks pretty good to me, and so I think this PR will be moving forward if no further comments from other guys from the community. So I think the next thing the Joe can do is get the PR ready. So I just leave a small comments on that on the PR.
Yeah, I see that.
So
Oh,
I think you can get the
follow up
PR
on the
ready,
comments.
and then no further comments. We can finish it.
Yeah, we don't have to
Okay.
wait until Joe comes back, Kevin. Yeah, there's like one minor comment we can
Okay.
Okay.
move it forward.
So do you think we need to move the rest topic to the next meeting?
I guess if you
Yeah,
could review
we
it
can do
before
that.
that, and we can
Yeah.
Okay.
definitely go
Yeah.
go through that.
Okay.
Yeah.
Cool. So see you next time.
See you. Thank
you
you,
so much.
See you.
Thank you so much.
Thank you.
Great meeting you here. Bye.
Bye.